Okay, again on page 19, let's finish example 2 here and graph the line that is described. So we're going to go through negative 3, 1, which is a point on the graph, and it's going to have a slope of negative 2. So we got a point and a slope. So we're first going to plot this point, negative 1, 2, 3, up 1. So we're going to plot the point. Then the slope we're going to need to write as a fraction. So this is going to be negative 2 over 1. So our rise is going to be negative 2 and our run is going to be 1. So from the point that we just plotted, we're going to go down 2 and right 1. Down 2, right 1, down 2, right 1, down 2, right 1, up 2, back 1, up 2, back 1, up 2, back 1, and then connect it, and we have our line drawn. All right, the next example, example 3, we want to graph the line for each point slope equation. So this time it's not given to us specifically. So number 1, we're going to have to recognize that this is in point slope form. So we have to have that formula memorized so well that we recognize the fact, oops, it's on the other page, I can't show you. We've got to recognize the fact that we have y minus y1. So here's my y1 is equal to, and our slope is going to be in front of this parentheses. So our slope is negative 1, and then this is going to be my x1 here. So m for this problem is going to be the coefficient in front of that parentheses, so negative 1. And if I write it as a fraction, it's going to be negative 1 over 1. And our point will be x1. So remember that the formula has a minus in it, so minus 2 means that the x was a 2. And then minus 3 means that my y value was a 3. So x minus 2, y minus 3. So now I want to graph it. So I'm going to first plot the point, which is 2, 3. So I'm going to plot my point. And then I'm going to use my slope here, negative 1 over 1. And that tells me I'm going to go down 1, right 1, over and over, down 1, right 1, and plot those points so that I can connect it and get a picture of the line right here. All right, so let's do that one more time for part B. And when we do it this time, for this, we see that our m is going to be equal to, again, the coefficient in front of the parentheses, so 5/3. This is my y1, and this is my x1. So x1 is going to be a 1. Now, y1, this is plus 4, and the formula has a minus, so that it had to have been a minus 4. So that y1 is going to be negative 4. So I'm going to graph my point first. So here's my point. 1, 1, 2, 3, negative 4, which plots right here. And then I'm going to use my slope, which is 5/3. So I'm going to rise up 5 and run over 3. So up 2, 3, 4, 5, run 1, 2, 3, 1, 2, 3, 4, 5, run 1, 2, 3. And I can't go backwards any, so graph's not big enough. And so there we have that line. For example 4, we're going to write the equation of a line passing through the point 0b with a slope of m and a point slope form. So we're going to use point slope form. So notice it directs me there. So I'm going to do, this is going to be my x1, this is going to be my y1. So I'm going to say that y minus b, that's what that is equal to, and I'm going to use m, and then x minus 0. I'm going to then simplify it so I can solve for y. So I have y minus b. When I distribute my m, I get m times x is mx, and then m times 0 is 0. Then I want to solve for b, so I'm going to add b to both sides of the equation. I have an equation, so I can do that. And it's going to leave me with y is equal to mx plus b. So what we've done here is we've gone from point slope form to slope-intercept form, where 0b, of course, is the y-intercept. So to transform from point slope to slope-intercept form, you're going to use the distributive property and multiply m times x and m times x1, and then add or subtract to solve for y. So let's try that in example 5. So first we want to write, it says write it first in point slope form. So I'm going to say y minus my y1, which is -3. So minus and minus gives me plus 3 is equal to the slope, which is 3/2, open parentheses, x minus, and then my x1, which is 2. So now I have it in point slope form. And I want to change it now to slope-intercept form. So to do that, I'm going to first distribute. So I'll have 3/2 x, and then 3/2 times 2. The 2's are going to cancel, and that's going to leave me with 3. And over here I had y plus 3. So then once I do that, then I want to solve for y, and I want to subtract 3 from both sides. And that's going to leave me with y is equal to 3/2 x minus 6. So you can see that this is in slope-intercept form. It's solved for y. Y equals, here's my slope, 3/2, which of course matches that slope. And then this would be my y-intercept. So this is slope-intercept form. So to kind of show that the two things do tie together, we're going to come up here and graph the line that's described. So 2, -3, 1, 2, 3, has a slope of 3/2. So up 1, 2, 3 over 2, up 1, 2, 3 over 2, then down 1, 2, 3, and back 2, and connect. And notice that when I do that, it has a y-intercept of -6, which is what we would have expected right there.